Alright guys, in this section we're going to look at two things, indefinite integrals and net change. To be honest, I'm not sure why these two things are stuck together in the same section. But anyway, first up, we'll look at indefinite integrals. Indefinite integral is really just another word for general antiderivative. So if we're given this indefinite integral to do here, we've got the integral symbol, the function, and then the dx. The dx on the end tells you that x is the variable we're integrating with respect to. If you had something like rx dx, that would tell you that you're integrating with respect to x, not r. So anyway, this is a pretty short problem. If you integrate this, x squared integrates to give you 1/3 x cubed. X gives you 1/2 x squared. And sine x, if you integrate that, you get negative cosine x plus c. That's it. This next one's even shorter, although it requires a little bit more specialized knowledge. Looking at that, what is 1 over 1 plus x squared? What's that the derivative of? It's the derivative of arctan. So this is going to give you arctan of x plus c. So let's look at the difference between an indefinite integral and a definite integral. Definite integrals, we've learned those and thought of them largely in the context of areas. But it turns out definite integrals and indefinite integrals, they're very similar. The difference is the definite integral has endpoints, is from a to b. Indefinite integrals don't. With a definite integral, if you evaluate it, it gives you a number. But indefinite integrals, when you evaluate those, what you wind up with is a family of functions that ends in plus c. Reason I say a family of functions is this right here doesn't just represent one function. For any value of c that we plug in, we get different functions. So we get a family of functions when we do an indefinite integral. And as far as like getting a computer or a calculator to do it, definite integrals are actually really easy to compute, or at least to estimate. So your graphing calculator can do it. Even some scientific calculators can do it. This one has a integral button right. Let's see right here. So this thing can do integrals by approximations. But if you want to do an indefinite integral on a computer, you need something fancier, some sort of computer algebra system or something like Maple. You can also do it with a calculator that has a CAS built in, a computer algebra system. All right, there is one thing I want to do with indefinite integrals. We can use indefinite integrals to well, what I want to do here is verify some indefinite integrals. Integrals are harder than derivatives. So for instance, this right here, this integral that we're given here, that's a tough integral to do. We haven't talked about how to deal with this yet. So what I want to do is just show we can, if we're given this though, and we're given the answer, we can verify it by taking a derivative. So let me show you what I mean here. Let's see, I've got a cat joining me. This is Veronica. Veronica is 14 years old, I believe. Yeah. But anyway, she's joining us for this problem. If we want to verify this, what we can do is take the derivative of x squared cosine x, and the derivative should give us back this. I guess technically I should put the derivative of x squared cosine x plus c. When I do that, it gives me, by the product rule, I get first times derivative of the second plus second times derivative of the first, and then plus the derivative of c, but that's just plus 0. Then we have to look and check, is this equal to this? And the answer there is yes. Cosine x, 2x is here. then minus x squared sine x is here. So yeah, we can do that in verified, even though if we were just given this integral to do, we wouldn't be able to do that yet. You'll learn how to deal with that sort of integral in Calc 2. But let's do this next one. Verify that the integral of natural log x is this. So we'll take the derivative of x ln x minus x plus c. And again, I've got to use the product rule on this bit. So I get first times derivative of the second plus the second times derivative of the first. Then derivative of minus x is minus 1. Derivative of c is 0. So notice what we get here. This is 1 plus ln x minus 1. That just gives us ln x, which is what we were looking for. So we're able to verify this even though we can't do that integral over there yet. All right, that's it for this part of this section. So we'll stop here.